Hey Frank, can you help me with number 11?
Did you just say the F word?
Rachel, you're coming with me.
To begin this problem, we look at what we're given. First, we know that the patrol car is parked 50 feet away from the building. We know that theta is rotating at 30 revolutions per minute, and we're trying to find how fast x is moving when theta equals 89.9 degrees. First, we take 30 revolutions per minute and multiply it by 2 pi in order to convert it to radians, which will give us 60 pi radians per minute, which will then equal our d theta dt. Now, because we're working with an opposite and an adjacent side, we're going to use tangent. Tangent of theta equals x over 50. Now, to solve for theta, we're going to take the inverse tangent of both sides, which will give us theta equals inverse tangent of x over 50. Now, because we're trying to find speed, we're going to take the derivative, which is a rate of change. But, however, inverse tangent has a rule. The derivative of inverse tangent is inverse tangent of u equals u prime over 1 plus u squared. Let u equal x over 50, which will then let the derivative of u, which is u prime, equal 1 over 50 because the derivative of x is simply 1. Now we have the equation d theta dt equals u prime over 1 plus u squared, with a dx dt kicked out implicitly because we're working in terms of x. Now we take the equation we previously used, which was d theta dt equals u prime over 1 plus u squared dx dt, and we plug in. D theta dt equals 1 over 50, which we discovered was our u prime, over 1 plus u, x over 50 squared. Now, you square the top and the bottom, and you get 1 over 50 over 1 plus x squared over 50 squared. Now, we bow tie the bottom of this fraction, and we get 50 squared plus x squared over 50 squared. Then, this 50 cancels out one of these 50s, and you're left with 1 over 50 squared plus x squared over 50. Now, you can't leave a complex fraction like that, so you're left with super fast flip. And you multiply 50 to the top, and you get 50 over 50 squared plus x squared. So now our equation is d theta dt equals 50 over 50 squared plus x squared times dx dt. Now we must go back and solve for x. So tangent of 89.9 degrees equals x over 50. Multiply both sides by 50, and you get x equals 50 tangent of 89.9 degrees. Before you plug this in the calculator, make sure your calculator is in degrees, and you'll get the answer 28,647.86. Now we can begin plugging into our equation some more. We plug in for our d theta dt, our 60 pi, which we figured out earlier in the problem. And we have 50 over 50 squared plus 28,647.86 squared times dx dt. Now, in order to solve for dx dt, we need to divide by 50 over 50 squared plus 28,647.86 squared. Dividing by a fraction is the same as multiplying by its reciprocal, so we have 60 pi times 50 squared plus 28,647.86 squared divided by 50 equals dx dt. But because 60 pi is in radians, we need to now put the calculator back in radians. And you can plug this in, and you get dx dt equals 3,093,975,091 feet per minute. But because Mr. Mantinaos prefers miles per hour, we now convert it using 5,280 feet per 1 mile and 60 minutes per 1 hour, and we get the answer 35,158,807.85 miles per hour.